Hello and welcome back. This is another exciting module where we'll explore Model Context Protocol and its integration with ADK. So in the previous module, I have shown you how to use tools. We wired exactly two tools with an agent, and we have seen how it basically uses them to perform various actions. But as you can imagine, as the list of tools increases, we are going to have a challenge with the agent talking to multiple tools. And these tools are also used from multiple agents. So you may want to create reusable agents that multiple agents might want to consume. So on one side, you have number of agents, and then on the other side, you have n number of resources. And to make sure that each of the agent effectively uses the tool, you have to create a grid of into n. Now that's pretty complex to manage, and it becomes a very complicated matrix to define and manage. So to avoid that, we have a protocol, a standard protocol introduced by Anthropic called MCP, or Model Context Protocol. Now this is a mechanism where you can standardize your tools without worrying about who is going to consume that. Now, a tool defined in MCP can be consumed by an LLM directly because most of the LLMs and their SDKs now support MCP natively, or you can integrate that with agent frameworks like ADK, Crew AI, and LangChain. So irrespective of how you are creating an agent, you can define your tool as an MCP and it becomes a standard protocol. Anthropic introduced MCP as a USB-C equivalent of tools for developers. So you can plug in, and you can, once you have a USB-C adapter, you can connect even other devices that don't use USB-C, like USB-A and USB-B and various other type of devices. So similar to how a USB-C adapter gives you a standard interface to connect peripherals, you can use MCP to basically define your tools once and use them multiple times and with a very diverse set of consumers like LLMs and agents. So that is a brief introduction to MCP, and I'm going to launch what is called as the Model Context Protocol Inspector from my command line. And this tool will help us explore the tools effectively from the browser. So let me switch to the browser, launch another window, and access the protocol, the MCP protocol inspector. So the MCP protocol supports multiple transport types: STDIO, SSE, which is server sent events, and streamable HTTP. This is the most preferred, but to keep this simple, I'm going to use STDIO. And NPX is the executor for Node. So if you have executables that created out of Node.js, you will invoke NPX. So there is a general purpose open source MCP server called server anything, and it is written using TypeScript. So we are going to invoke that using the STDIO transport type. And when we click on connect, it basically connects to the server, MCP server. And when we go to tools and click on list tools, you'll see this MCP server supports a variety of tools. So it supports echo, which echoes back the input. It supports add, that simply adds two numbers. There is printenv, which will print the environment variables running on the host or the server. And you can get a tiny image, which is going to be a base64 encoded image that is going to be sent by a tool. So there are multiple other tools. Now what you can do is you can select any of the tools. For example, we'll select get tiny image and click on run tool. So this is a tiny image, that is the text, and you'll see that it returns a tiny image of MCP logo. So you can even explore other things. For example, you can click on add in the inspector, tool inspector, and click on run tool. So this is going to invoke the tool and it comes back with the response. So MCP inspector is a very powerful tool to debug and to test a variety of MCP servers, both STDIO, which is local MCP server or a remote MCP server based on the HTTP, the streamable HTTP protocol. So our goal is to invoke the same sample MCP server called server anything from ADK. So let's switch to the notebook and see what steps are involved in that. So first we will import the modules, and when we are importing the module, we are making sure that we have MCP tool.mcp toolset imported, and we also have other MCP related imports. Refer to documentation for more details on how to integrate MCP with ADK, but these imports will make sure that we are basically enabling ADK agents to consume MCP tools. Then we will create an MCP image server by passing the parameters for stdio. So npx-y followed by model context protocol server anything, and then the tool filter is get tiny image. So this is the actual tool that we want to invoke from the MCP server, that's called server anything, and it is written using Node, so we'll use npx. But if you have written an MCP server using Python and you want to invoke that, then you would actually replace npx with a Python interpreter. So Python followed by your code, and if you are sending an auth token, so you can even send that as a parameter. Now this cell is basically responsible for defining the MCP server. So once we are done with that, then we will create an agent called image agent, and this image agent uses Gemini 2.5 Flash and uses an MCP tool to generate images. And for the tool, we are actually sending the MCP host. So if you have created the MCP toolset in the previous step, you can simply pass that here. So MCP image server, that configuration has everything that ADK needs to invoke the appropriate tool. So we just wired up an MCP server and a specific tool within the MCP server with ADK agent. And then we go ahead and create a runner. So this is going to help us invoke the agent, and we will now invoke run debug by setting verbose to true. And this is going to create a new session, and it's calling the tool get tiny image, and this is the tiny image. Now obviously we are not showing the base64 encoded image, so there is a helper function here which will show the base64 encoded image within the Jupyter notebook. So we'll import image as IP image and import base64. So we'll now decode the base64 image into a rendered image within the Jupyter notebook. So you can actually see that it is sending a tiny image of the MCP logo. So this is a pretty straightforward approach of using MCP servers with ADK. Now you can also change this from stdio to a HTTP streamable HTTP protocol. I'll cover that in the future sessions, but to get started, it is better to use an stdio transport because you have a lot of control on which server you're launching, and we are not using any authorization and authentication here. That's another advantage of using a local MCP server. But in production, you will most likely use a remote streamable HTTP server with authentication, mostly based on OAuth 2.0, and it is an advanced concept where you will authenticate with the MCP server and then you get authorized to use certain tools. So we'll cover that in the upcoming sessions. So that's about how we use MCP with ADK, and I'm going to put this notebook along with the commands needed to run the inspector on GitHub, and the link will be in the description below. So I hope you found this useful. Thanks for watching, and I will talk about callbacks and why they are important in the upcoming module. Stay